The first big, I would say, feature for the future is that we'll be able to explore the universe in a totally new and different way, having to do with gravity instead of electricity. The second, maybe even longer, is that because it took so long to get gravity and measure these gravitational waves, is because they do so little. They go through space without doing much. They bend space a little bit. And what that does is give us, if we can do it, the opportunity to go back all the way to gravitational waves that were made when the universe was born, at the very, very earliest moments of the universe. With electromagnetic radiation, what we do now is only goes back to 400,000 years after the Big Bang. So we guess and extrapolate and have theories what was like before, but the potential is there with gravitational waves to probe all the way back and see what happened when the Big Bang occurred. In the short term, meaning 10 years or something, I think there's two good chances. One is to detect gravitational waves not the way we did, but at lower frequency. And that will give, if it's done well, can give us some information about the early times. And the second is to see what we call the imprint of gravitational waves on the early background signal that people measure, which is the main information we have on the early universe. So I think indirectly, gravitational waves will give us a probe earlier. Eventually, we need new instruments that will look at gravitational waves directly that go back to the very earliest times. We don't know how to do that today, but the opportunity is there because we know the gravitational waves are there. We know they weren't absorbed. We're going to need better instruments than the one we have.